Do y'all have your unit circle?
No, I forgot it at home. I forgot everyone. I do. I have mine.
If you need, I can get extra copies.
Really cool. I heard it today.
Let y'all borrow this one for today. And the reason the unit circle is nice, especially for this here, is because when we're trying to find those values, or a given value for sine, cosine, tangent, especially those three, it's going to be nice with the unit circle because sine inverse, cosine inverse, tangent inverse work, but sine inverse is only going to give us, let's see, you'll be able to write. So sine inverse will give us angles between pi over 2 and negative pi over 2. It's just going to give us these here. The same is true for tangent inverse. And for our fourth quadrant down here, for us to get an angle that we need, we have to convert it from a negative angle back to a positive angle. So that really doesn't help us much. Cosine inverse is going to be between 0 and pi, which is fine. We don't have to convert any negatives, but we do have to find the other one. Because for sine, it's going to be either have an angle in the first and second or third and fourth. Cosine will have one in the first and fourth or second and third. And tangent will have it in the first or second, third, fourth. We have two, so it would give us one with using this in the calculator, but it wouldn't necessarily give us the other one, because most of these values will show up twice. And the unit circle will give us those values. We don't necessarily have to go hunting for them after we find one. Does that make sense? Okay. Now, with most of these here, with solving, getting it equal to 0 is kind of a first step. And it works with most, because when we solved the higher degree polynomial functions or our polynomial functions in Algebra 2, getting it equal to 0 is one of the first main steps for us to solve. So here, cotangent of x times cosine squared of x is equal to 2 cotangent of x. It'd be nice to get this equal to 0. And we can do that by subtracting 2 cotangent of x from both sides. Because on our left-hand side, we'd have cotangent of x times cosine squared of x minus 2 cotangent of x is equal to 0. Questions on this here? Yes. So, why we can't subtract them? Because they're not necessarily like terms because of cosine squared. Because we can think of, because cotangent is shared in common with both, yes? But because of the cosine squared, these aren't necessarily like terms. Does that make sense? Because we can combine them, yes, because these are being multiplied, so we can't necessarily just subtract. But that is the right thought because they do both share cotangent of x, yes? So what can we do? We can factor it out. We can factor cotangent of x out of both terms. And if we factor it out of the first, all we're left with is cosine squared of x minus, when we factor the cotangent out, all we're left with is the 2. Now, part of the reason that this is nice and this is helpful is if I factor it out, we now have what? Two things being multiplied together that equal 0, yes? 0 product property. The only way I can multiply two things together, or two or more things together and get 0, is that one of those two has to be 0. And that's why this is helpful, because it's telling us that cotangent of x is equal to 0, or cosine squared of x minus 2 is equal to 0. Questions on how we got to this point here? We're good with getting to this point? Yes? Now, as a side note, because again, we did have that cosine squared, we didn't use any of our trig functions to get there. Yes? Because normally we've seen some of them were applying our trigonometric, or our Pythagorean identities. And then it is cotangent squared of x plus 1. In this one, I am always getting flipped. We have these here. Well, we have it in terms of cosine and cotangent. Well, cosecant is our 1 over sine. That doesn't really translate well. We'd have to do a lot with it. Y'all see that? It's not helpful. Changing cosine squared into 1 minus sine squared isn't going to help much here, because we do share cotangent. We can factor it out, and we get to here just fine. I don't have to mess with anything else. I don't have to try to get anything to be the same, because we do have two equations, both equal to 0. And in either case, our cotangent of x equals 0. The only trig function we have is what? Cotangent. It's all terms of cotangent and numbers. Our other one, cosine squared minus 2, we do have cosine being squared, but the only other thing with it is a number. We don't have another trig. It's not cosine and sine, tangent, cotangent. We don't have two trig functions trying to work together. Y'all see that? So the only reason I would try to use these is if I cannot get it all in terms of sine, cosine, tangent, one trig function. Now, out of these two here, let's work with cosine squared minus 2 first. So the first thing we'll do is get the cosine squared by itself. We can add 2 to both sides, which would leave us with cosine squared of x is equal to 2. What would we do next? We would square root both sides. Square root of cosine squared is cosine. Now the square root of 2 is really just square root of 2. So we have cosine of x is equal to positive, negative square roots of 2. We can look at the unit circle and see if, again, unit circle would be x values. If any of those x values gives us the square root of 2. Well, I don't think that's the case, is it? Because pi over 4 square roots of 2 over 2. Well, I'm going to use the calculator. Clear that out. Switch over to radians. So cosine inverse of the square root of 2 there is domain error. Let's see why. Approximately the square root of 2 is 1.41421 going on. Cosine and sine. Cosine's value, the biggest value it can have is 1. The smallest it can have is negative 1. 1.41. So what we're saying here really is that cosine of x is equal to positive or negative 1.41. Is there any way for cosine to have a value bigger than 1 or negative 1? No. So cosine squared of x minus 2, there are no values that work for this here. It does not have a solution that works. That would make that be 0. Does that make sense? And graphically, cosine of x squared minus 2 it never touches the x-axis, it is not equal to 0. It doesn't work. So that part is done. Now we're trying to find out where cotangent is equal to 0. Yes, the tangent, cotangent is not listed directly on the unit circle. But cotangent, a part of our identities, is cosine of x over sine of x, because cosine and sine are on the unit circle. And for a fraction to be 0, the numerator has to be 0. That's the only way this works. Because if the denominator is 0, if sine is 0, it is undefined. Because anything divided by 0 is undefined. If the numerator is 0, then the whole thing is 0. So really, we just have to look at the unit circle and see what values of x will make cosine our x value be 0. And it's at one of our 4 quadrants, either 0, pi over 2, 3 pi over 2, or 2 pi over 3, or 3 pi over 2. And I believe it is, one of them is pi over 2. And the other is 3 pi over 2. And those are our 2 there. Now, part of the reason I just scrolled back up is I wanted to see, does it tell us, restrict our values of x, our angles? Well, no. So we have to add the period back in. Now, for cotangent, just like tangent, its period is pi units. It repeats every pi. So we have pi n added to it. So these are the 2 that work. But incidentally, pi over 2 and 3 pi over 2, pi over 2 is straight up, yes? I'll draw it out. Might be easier to see. 3 pi over 2 is straight down. What's the distance from pi over 2 to 3 pi over 2? Pi. 180, yes. Those are the same, pi or 180. So when I add pi to pi over 2, I get 3 pi over 2. When I add pi to 3 pi over 2, I get the coterminal angle for pi over 2. So if you list both of them, that is correct. Those are the correct angles. But they do repeat themselves, so we don't necessarily need it twice. So we can condense those 2 statements into just x equals pi over 2 plus pi n. Questions on this here? Sine squared equals sine of x. So what we're trying to do is find out where these 2 are equal, yes? Now, we didn't do this on the last one, but I could come over here and say sine squared of x, delete, sine of x. So where those intersected across is where it's going to be equal. But that's kind of hard to tell based off that graph. And so, just like with the last one, it might be helpful if we got this equation equal to 0. Now, it doesn't matter which one we subtract from both sides, because we could have subtracted sine squared from both sides. We could subtract sine from both sides. Either way, we'll get to the same answer. I subtract sine from both sides because I want to keep my squared term positive if I can. Questions on this so far? Now, just like the last one, we don't have to use the Pythagorean identities because it's all in terms of sine. We don't have cosine. We don't have these mixed trigonometric functions. But there's something in common with both terms. Sine of x. So just like the last one, I can factor out the sine of x from both terms. And if we factor a sine of x out of sine squared of x, we're left with sine of x. And when we factor sine out of sine, we get 1. So we have sine of x times sine of x minus 1. And again, just like the last one, if we have two things multiply together to equal 0, one of them must be 0. Questions on this so far? Sine of x equals 0. Unit circle. We're just looking for which one has a y value of 0. One of them is, well, 0. Because on the positive x-axis, the y value is 0. So sine has a value of 0 at 0, funny enough. What other spot does the y value 0? Pi. So we could say 2 pi, but 2 pi would be the same as 0, because we do have that period of 2 pi n. So it does wrap around back to 2 pi. And because, again, they didn't restrict our angles, bless you, we can add 2 pi n. Now, I've done it a few times, and we've said that there are certain ways we can condense and merge, yes? And when you're looking at the unit circle, and we have two of these values, if they are completely opposite, they end up making like a straight line on the unit circle, we can condense them. Well, 0 and pi make a straight line, just the x-axis, yes? So we can combine these two here and just say x is equal to 0 plus pi n. Now, the way that we pick between 0 and pi, in this case, is we pick whichever one's the smaller of the two angles. And yes, that's a little funny to write, yes? What's 0 plus pi n? Just pi n. Because if n is 0, because n can be any integer, so if n is 0, well, the whole thing goes to 0. It's our first one. Yeah. It's kind of funny that works that way, but it does. Sine of x minus 1 is equal to 0. Well, we can add 1 to both sides. And if sine of x is equal to 1. With sine and cosine, there is only one angle that gives us 1. And for sine, it is pi over 2. And the reason for that is because straight up on the or the y-axis is our sine value of 1. Straight down, 3 pi over 2, it is not 1, but it is negative 1. Those are two different values. So here, because sine of x equals 1 or negative 1, cosine equals 1 or negative 1 will only have one angle. Pretty much the rest have 2. Those are the only ones that don't. And those are our answers. Questions on this here? What do we think of this so far? It's all right. I mean, getting to solving, getting sine equals 0, sine of x equals 1, I think we feel okay with that. That's not too different. It's a little, but not too different than what we've done in Algebra 2. The jump from there to our angles is a little weird. Because again, we're just referring back to that unit circle. Where is sine equal to 0? What value on the unit circle we have sine 0 or sine 1? And once we find that, we can find the angles. And we do have to go around the whole circle. Any other questions on this here? Yes. Okay. Again, yeah, sometimes it's, for some reason, it's easier having me up here. Because sometimes I can ask those questions that are keeping us stuck. And with most of these here, all the ones we've done so far, really getting it equal to 0 is going to be the first big step with all these here. Especially if we start out with a single trigonometric function, or even if we have more than one, if we have something in common with those, getting them together and trying to factor. Here, they have something in common. We get them together, factor, we can solve. Does that make sense? And if you do get stuck, take a picture of it, email me. And hopefully I can give you that push to get going. Yes? Mm-hmm. Now this one's a little different. So it wants us to find all the solutions of 2 sine squared of x minus sine of x minus 1 is equal to 0 in the interval 0 to 2 pi. So the reason this is different is it's told us that our angle, our values of x, have to be between, it can be equal to 0, but not 2 pi, but it's stuck on the unit circle. So all that means is where we've been adding 2 pi in or pi in afterwards, we're not going to do that because those angles are outside of 0 to 360, 0 to 2 pi. So once we get our answers, we are done at that point. So looking at this here, are all of the trig functions used in this equation the same? Not so much with powers, but are they all the same trig? Yeah, they're all sine. So that means the Pythagorean identities, we don't need them. Because as long as it's all in terms of sine, cosine, tangent, we're good. Now, this here is factorable. So is their greatest common factor between these 3 terms? Sine x is in the first 2, but not 1 is our minus 1.
So why do we do the 3 spaces thing?
2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So since the third term is negative here, one's going to be positive, one is going to be negative. Our next step in factoring is to find the factors of the first and third term. Well, 2 sine squared of x, so the only way we can get sine squared is, well, sine times sine. So the first one is going to have sine of x. Second set of parentheses will have sine of x in the first. It's kind of the same as our x squared. So realistically, I'll write this to the side. What we're really looking at is 2x squared minus x minus 1. These are essentially, for what we're doing, the same type process, same type equation. But instead of x, we have sine. Does that make sense? And if it helps, rethinking of it with sine all in terms of x, we get to the same spot. Questions? Because it is a little stretching because we're trying to take something we know and apply it in a little bit different way. Factors of 2. So we're going to stick one of the 2's with sine, either with the first one or the second one. This point doesn't matter which because we'll check it here in a minute. Factors of the third term, factors of 1. 1 and 1. Now we can check and make sure we got this right, because we're going to multiply our 2 sine of x and negative 1, which will give us negative 2 sine of x, and positive 1 times sine of x is plus sine of x. Excuse me. Negative 2 sine of x plus sine of x, negative 2 plus 1 is negative sine of x. Is that the middle term we wanted? So these here are the correct factors. And again, part of the reason we factored it is to help us try to find the solutions. Because in factored form, I do have 2 things being multiplied together that equal 0. So according to the product or zero product property, one of them has to be 0. So either 2 sine of x plus 1 is 0, or sine of x minus 1 is 0. Now at this point, we just have to solve each of these here. Now our 2 sine of x plus 1, we can subtract 1 from both sides, telling us 2 sine of x is equal to negative 1. Then we can divide both sides by 2, telling us sine of x is equal to negative 1/2. The other equation, we can add 1 to both sides. Telling us sine of x is equal to 1. Okay. Questions on how we got sine of x equals 1 and sine of x equals negative 1/2? We feel good getting to there, yes? Unit circle. So we can do the negative 1/2 first. So again, signs in the y values, we're just looking around the unit circle for negative 1/2. 7 pi over 6. And what else? There's 2 of them. Now we need to see where sine of x equals 1. Yes. Which is straight up pi over 2. And that's the only one, because straight down is negative 1, so that doesn't work. So we have.
How do you know if it's in y or in x?
So sine is, so the way we know x or y with those is the sine value is going to be y on the unit code. Yes, up in the top right corner. Because
Minus y cosine x.
yes. So every point, that ordered pair on the unit circle is cosine comma sine. Cosine's the x, sine is the y.
Is there going to be any tangent?
So tangent sine of a cosine.
Oh, okay.
But also on the unit circle, if you notice the 3 values, well, technically 5 because we do have 1 at 0, 1 at pi over 2. The 3 values we get here really are repeated in the other 3 quadrants, but the signs just change from positive to negative or negative to positive. And if one of them, so negative 1/2 for sine, yes? We found the first one at 7 pi over 6. The other one was also 11 pi over 6. With sine and cosine, because if we get 1, they're all pi over 6, because let's say positive 1/2. Well, sine is positive 1/2 at, if you look at the unit circle, it's pi over 6, yes? So sine is positive 1/2 at pi over 6. It's 5 pi over 6. You all see that there? Because if it is 1, the denominator normally, especially with the ones that aren't 0, pi over 2, pi, 3 pi over 2 will keep the same denominator all the way around. So for tangent, if you see that it is pi over 4, for the positive one, we need the other positive. The other positive is going to be over here at 5 pi over 4. If it's negative 1 for tangent, it's going to be over here at 3 pi over 4 or 7 pi over 4 because it deals with pi over 4. And it's really delving more back into our coterminal angles, or reference angles, not coterminal. Because 3/8 pi over 4, well, the distance here, this reference angle is pi over 4. Here, from pi to 5 pi over 4 is reference angle of pi over 4. This reference angle is pi over 4. The reference angles are the same. That's why these match up. Does that make sense? So it's less that I'm actually trying to find them and I'm picking them out randomly. I just know that tangent is negative, or not negative 1, positive 1 at pi over 4. I need to find out when it's negative 1. Well, tangent's negative in the second and the fourth, so it's a reference angle of pi over 4. We get those two there. Does that kind of make sense? It's an odd thing. It's more we're manipulating what we need and trying to analyze the information to get where we want. Does that kind of make sense? It's one of those odd things that's complicated and not complicated. Because once we start seeing how it works, it makes it nice. And we can manipulate it the way we need. Yes, let's do one more for sure. That was the computer kicking on. All right. We ready for this next one? 2 sine squared plus 3 cosine minus 3 equals 0. So for this one here, we do have it all in terms of cosine, yes? We have sine squared. Well, I need it either all in terms of cosine or all in terms of sine. Pythagorean. Now for this here, it's going to be easier to turn it in terms of cosine than it is sine. And the reason I say that is because if we want to do this in terms of sine, I have to find a way to turn cosine, or 3 cosine of x, into sine. That might be a little bit more to it. But sine squared plus cosine squared is equal to 1. Or our other one that we had was that sine squared of x is equal to 1 minus cosine squared. So that means that I can replace this sine squared with what? Yes, I can replace it with 1 minus cosine squared of x. Because now we've taken it from an equation that had sine and cosine to an equation that just has cosine. Questions on this here? We need to distribute 1 times 2 is 2, minus 2 cosine squared of x plus 3 cosine of x minus 3 is equal to 0. Two minus 3. Negative 1. I say negative 1. I write the negative, and then I don't write the 1. Okay. We feel good getting to this here. Okay, we're going to have to factor. Yes, I don't like factoring with a negative in front, especially our squared term, yes? So I'm going to show you this here. Negative cosine of x squared plus 3 cosine of x. Yes, thank you. Because that will change the entire equation. 2 cosine of x squared. Okay. And I did intentionally leave the negative off. Because what I did is I'm dividing everything by negative 1. Because our normal function is this here. Now let's trig. Okay, it's going to show us about the same thing. All right. Now, I divided by negative 1. It does look like a completely different function, yes? But the places where it does cross the x-axis, so it is telling us one of the values is 0, are going to be the same. Changes the rest of the function, but it does not change our solutions, our x-intercepts. Because I don't know about y'all, I would rather factor or divide that negative out instead of working with negative 2 cosine squared, work with 2's cosine squared of x. I'd rather try to factor this than try to factor negative 2 as our A, our first term. Two sets of parentheses with 3 spaces. Third term is positive, so the signs are the same and match the sign of the middle term, which is negative. Now, the only way we can get cosine squared as well, its factors are cosine of x and cosine of x. We'll need it in both. Factors are 2. 2 and 1. We just need to put 2 in one of the spots. Now, I will tell you this. If the signs are the same, it's really not going to matter. Just pick one of them. Especially since the factors of 1 are 1 and 1. So no matter where we put it, it's going to give us the same setup. It's just flipped. Negative 2 cosine of x minus cosine of x is negative 3 cosine of x. Since we do have 2 things that multiply together to equal 0, one of them must be 0. Solve. Add 1. Now we need to find out where cosine of x is 1/2. Again, this time we're looking at the x values. Which is pi over 3, or not 7 pi over 3. Five pi over 3, correct? Well, only reason I could get there so quickly is I did look over, cosine of x is equal to 1/2 at pi over 3, yes? The only other spot where cosine is positive is in the fourth quadrant. That's first quadrant? Or is it? Okay, I think I've got that right with pi over 3, yes?
Wait, what did you say?
Cosine, x value is 1/2.
Yeah.
Is pi over 3, yes?
Yes.
Now, the only other place where cosine is,
Pi over 3.
or it's 5 pi over 6.
Yeah,
Right.
5 over 3.
So x. Cosine's x. Yeah. So there. So it's negative in the second, negative in the third,
Oh, positive in fourth.
and positive in the fourth. So it's positive in the fourth, yes? Well, the reference angle is pi over 3, yes? Or pi over 3 short of 2 pi. So 5 pi over 3. 6. 6 over 3 is 2. But all you got to do is look at the unit circle. It'll tell you. We don't have to have that memorized. But since it's also restricted on 0 to 2 pi, those are our two answers. We don't have to do anything with it. Cosine of x equals 1. Only one spot.
Pi over 2. Oh.
Because here we're looking at x, which is 0. We actually saw that when we graphed it. That's it. We'll stop there, mainly because we're